Question 3, the function f of x equals x to the third is transformed to get function g of x equals -3, parentheses, x plus 2 raised to the third power. Which statement are true about function g? So we're really only looking at function g to answer these questions, but it's always helpful, I think, to type in the original parent function just to kind of get an idea of how we've shifted. So I'm going to type in y equals x to the third and look at the graph real quickly and see, okay, it goes through the origin. It flattens out right here at the point 0, 0. And then I know from my shift rules that +2, we get this confused sometimes. We can't remember if it's going to shift us left, right, up, or down. But once we look at a visual, we'll remember that rule. So I always like to have a visual rather than counting on memorizing the different shift rules. So we've got it, I'm going to type in x plus 2 and raise this to the third power. And then when we graph it, a couple things happen. First off, we definitely shifted left 2. And then also the orientation of the graph kind of changed. Instead of going up from left to right, it's going downhill from left to right. So real quickly, I'm going to do a quick, very rough sketch of what this looks like. I know it is going through this point here, and the graph generally looks something like that. So then let's go through the answer choices. The first answer choice, as x approaches -infinity. So as x approaches -infinity, recall x values go left and right. If x is approaching -infinity, that means we're looking at the left end of this graph. Okay, this is the left end of the graph. So is the left end of the graph approaching positive infinity? Well, yes, because the left end, as it moves left, is going higher and higher. It is going up forever. So this, we're going to check this one off. Next one, the y-intercept is 0, -2. Well, the y-intercept is where it crosses the y-axis. This is the point 0, -2. This graph, even though it's not exactly like what it looked like in the calculator, we can see either from my picture or this picture, it's clearly not crossing the y-axis at -2. We can see, though, the x-intercept. We've already talked about this. It is crossing at -2, 0. This +2 right here shifted that parent function left 2. Next, the domain is -2 to infinity. Recall, domain is referring to the x values, and x values go left and right. Well, if you look at the left end and the right end, this one's a little tricky, but it is like they're obviously both going up and down, but they're also very slowly, they're inching out toward the left, they're inching out toward the right, really at a slow pace. So they're going left forever and right forever. So the domain for this problem is actually -infinity to positive infinity. And we definitely know this can't be right. They're saying the leftmost x value is -2. Well, that's just not the case. -2 is the x-intercept, and this graph clearly goes further to the left there. All right, then finally, I'm going to switch up colors. As x approaches positive infinity, so that means we're looking at the right side of the graph, the function approaches positive infinity. Well, the right side of the graph is over here, and the right side of the graph is going downhill. So this answer really, this should be -infinity instead of positive infinity. And then finally, the range is -infinity to positive infinity. That is true. Range is the y values. Y values go up and down. Well, is this graph going up and down forever? Absolutely.